So as we were talking, this system can really be laid on in a number of ways. You can start off with using existing smartphones in order just to get better capacity, better throughput, better reliability in an existing network. And then we continue to talk about cellular communications, which means there's base stations and there's a cell around it. But eventually you get to the point where you can just have peer-to-peer communications with certain egress nodes, but you don't need base stations necessarily. And the third problem, which is really the holy grail, is how do you take care of the spectrum allocation problems? Because that is a completely man-made issue in terms of the allocation procedure, but it's a nightmare because it's a scarce resource. So how do you get it so that either you make it more efficient in terms of getting incumbents out, or you simply remove the need of actually allocating spectrum and make everything extremely wideband so that users themselves democratically take whatever spectrum they have, and there's an etiquette for doing it. And that was sort of the basis of one of the points of our papers, which was having wideband spectrum allocations that you don't need to allocate on a piecemeal by piecemeal geographically and to people, but rather allow everybody to use all the bandwidth they need and have an etiquette for sharing.
And that's only possible because of digital and things like direct sequence.
That's exactly right. And part of what that enables us to do also is have a spectrum of flexibility, if you will, between having high data rates and high range. There's always a tension at the beginning. You want to have high range because you may have very few users around you. But once you get to the point, you want very high capacity, but you have a lot of neighbors. And how do you fluidly move from one end to the other? And the manner in which we describe in our publications actually allows you to have both of those, not at the same time, but when you need to, you can have extremely high data rate for video applications, etc. But at other times when there's sparse surroundings, it allows you to have very high range and get to very long distances.
So now you've looked at both licensed frequencies, unlicensed frequencies. Is there kind of an ideal range, as far as the bands that this would work in?
So the difference between licensed and unlicensed is, in licensed bands, you are guaranteed some kind of reliability and throughput. So that clearly is the benefit. That's why cellular companies pay billions of dollars to get narrow slices of spectrum, because they own it and they can do whatever. But it's sort of a primitive way of assuring reliability. There are better ways of assuring very high reliability and very high quality of service without necessarily selling spectrum. But given all of that, you will continue to have some licensed spectrum for sure. But our preference is obviously to have predominantly unlicensed spectrum, because then the marketplace really evolves to have much more creative architectures in order to deal with it, and to have things like very high bandwidth, very high range, very high reliability, etc. In the original premise of our paper, since this was in countries where you're operating beyond the law, the whole concept of licensed spectrum is meaningless anyway. Right. North Korea's main problem is not that you're violating spectrum regulations, it's that you're a dissident. So in that context, it's clearly unlicensed and unregulated spectrum.
What sort of bandwidth would be ideal? I mean, I know in the talk, I think you talked something about 500 megahertz or something would be
From a conceptual point of view, the more the better. But from a practical point of view, because you have to have radios that actually are capable of delivering good linearity, and you have to have analog to digital converters that can sample. So 500 megahertz to a gigahertz is completely feasible in today's technology. You can have more, but probably that's a good quantum of spectrum to start with, and then see how you can add on. And in many cases, you can have things like channel bonding. So you can start off with some kind of spectrum, some amount of spectrum, and you can always bond more channels. You clearly want several hundred megahertz to start out with if you want to apply some of these interesting broadband techniques. And by the way, this is separate, not necessarily disjoint, but quite separate from some of the other infrastructure-free mesh concepts, which can still operate over narrower band channels. So there itself, you have a lot of benefits, and adding the broadband component just adds even more benefits.
And so from a a next step, it seems like, to some extent, this seems like ham radio with packet radio, right?
But anyway, I just want to bring up a point that, in fact, we talked about some of the internet radios, etc. The very first network, really, that operated with the protocol is the AlohaNet by Norm Abramson in Hawaii. That was a wireless network, and it was completely peer-to-peer, and it was sending across different islands. So really, if you look at it, we're going back in history to the very first functioning network and protocol that existed, and it was mesh, and it was and it was packet, and it was completely peer-to-peer, etc. So in a sense, things come back.
Well, I guess the big difference is now you've got software-defined radios that you can put in in these little devices. That's right?
True. That's true.
So from a kind of a pilot perspective, in one sense, it's kind of been proved in theory and in practice with the AlohaNet and so forth. But do you see any opportunities for kind of piloting this in anywhere?
Yes, I mean, I think at a pilot level, we would need to do it in some place where the spectrum is available to use. And I think that would mean unlicensed spectrum is probably the most likely candidate. And I think the other thing that's also happening is that we have this spectrum crunch or capacity crunch in mobile networks, where mobile usage is going up so much that actually may bring about this kind of the need for this architecture to enhance capacity of all the phones that we're using. So there's a very real possibility that we might start seeing this on our cellular networks even sooner than anywhere else. But in terms of piloting the network to enable freedom of speech throughout the world, that is something that we would like to see happen. That won't happen based on the cellular technology that's being developed today. It needs a special effort. And I think the other part of this is there are some programs that are sponsored by the State Department to enable certain small groups of people like dissidents or whoever to. And one of the things we realize is that those can all be targeted by a government or someone who's trying to stop them from communicating. Whereas if the network is everywhere, if everybody has the network, there's no way to target it. And so that's a fundamental, I think, leap that we have to make as a society, is to enable everyone to communicate all the time.
And I think, so I would say that there are maybe three scenarios I can think of that would result in reasonable pilots. One of them is the State Department. As Sri was saying, this is clearly a nice vehicle to see whether we can target dissidents and give them access to it. The second would be FEMA, or some analogous agency that's doing disaster recovery, because I think with a very low cost, you could actually set up a very nice peer-to-peer protocol communication system, and it would really help in their disaster situations. And the third, I think, would be simply to build a test bed, probably in an academic environment. But my inclination would be more to go towards one of the first two or something like that, because when you have a targeted focus in an application, it helps you resolve what you really need to build in what way. So either the State Department or something like FEMA would be extremely useful and good pilots to do at very low cost, and you could get it off the ground.
And from a hardware perspective, is it the type of thing where you could, literally use the existing phones, you think, in a pilot? Existing
phones, or you could do some, variant of it.
Like a little sleeve or something for a phone?
The technology part of it, there are lots of, communication chips out there, very straightforward. In fact, I'm not sure if it's on our papers, but we actually did a bill of materials analysis as to what it would take to build this kind of phone, and these are fairly inexpensive. And so the technology part in development is very straightforward to do once the motivation is there to actually have an application and say, this is the kind of demonstration system or pilot that we're going to do.
What about from corporations? Have you gotten any feedback from some of the larger? Because I could see where there could be some natural allies for an approach like this.
We haven't done a whole lot. Frankly, after we wrote the paper, because we were talking about Arab Spring a couple of years ago, we said, wouldn't we need if all these people are getting shut down, they can't do Twitter each other, and so wouldn't it be nice to design a system that they could use robustly? And so we came up with this, and then it started getting some interest. But we both have other things to do, so we've been busy with that.
Well, and that's one of the things I find really refreshing is you're not really here pushing an agenda. There's nothing in it for you guys, and you're in a medical health startup. You're actually on the infrastructure side of things, right?
Ironically. But I've had lots of my background has been a lot in Wi-Fi, etc. As is Sri's, which is all infrastructure free, but to a large extent. But so we haven't really pushed this as much. But every time we have mentioned it or we've discussed it, the interest is phenomenal. And you were there in the ComSoc talk that Sri gave, where there was so much audience interest. So I think it's worth pursuing a little further, and we'll probably start looking at avenues to push this, because both from a government point of view, as I mentioned, and also from a corporate point of view, in other words, what are the commercial applications of this? I think there's a whole range of possibilities that need to be explored, and so it really needs to be followed up a little more, right?
Well, and then hopefully this video will help convey that, and I really appreciate you both coming over here to give us an update on this.
Well, thank you, Ken.
So thank you,
appreciate it.
Thank you.